Hey, what's up guys? My name is Cherno. Welcome back to the Game Engine series. How's everyone doing today? We are going to be continuing on with the really cool C# stuff that we've been doing lately. We are going to be continuing on with our scripting engine. And today, hopefully, it's going to be a very exciting episode because we are going to basically create script components inside our ECS system and make it so that we can hopefully add some behavior to actual entities here today and program that in C#. So that's kind of the goal for today's stream. It should be pretty easy, to be honest, because we've done a lot of the foundational work. There's a lot of like API and a lot of like the way that we do things initially using Mono and C#, that is all very, very likely to change. In fact, I'm telling you right now, it will change. Because like obviously when we set this up initially, like the way that it's set up might not be, it's not going to support every feature that we might want, and also it's not going to be the most like efficient thing to do. However, the kind of, as a first step, I like to get stuff up and running and working with as little friction as possible, which is why we're doing things that way. Cool. So yeah. As usual, this will be published on Cherno Unplugged, so if you guys are watching on Twitch and you want to watch this stuff later, then I have a YouTube channel called Cherno Unplugged, which is kind of for more chill, long-form content. And of course, if you want to support Hazel and this kind of game engine series, then you can go to patreon.com/Cherno and get access to the full version of Hazel, which is actually like the full 3D version of Hazel, which is actually where this kind of C# engine and everything is kind of coming from. So we're architecting it in a very similar way to the way that it's done there. So all the code is already present there if you wanted to jump ahead. Cool. All right, without further ado, let's dive in. Let's take a look at what we've got here. So this was basically the result of like last week's stream. It wasn't much, like nothing actually in the editor, right? Everything was kind of just printed here, right? We basically were just able to create like a C# object, trigger that creation from C++. We have this kind of main.cs source file, which is written in C#, right? And it's part of Hazel Script Core, which is like our little C# library. And then from there, we're able to use our script engine to create like an object, call like a function, which is what we're doing there, and also call back into C++. So the cool thing is, aside from just being able to construct this, call the constructor, call these pre-message functions that are written in C#, calling them from C++, we can also define these kind of internal calls, native log vector, that kind of stuff, and then call them like from within our C# code, and that actually goes back into our C++ code for some of these internal calls. So I think script glue is where we kind of define that. So we would kind of began the architecture of how the C# C++ binding is going to work. All right, cool. So, let's see here. Where do we want to begin with this? So yeah, my idea basically is like, we've obviously got all the infrastructure up and running. We can call C# functions. We can call C++ functions from C# as well. All of that's there. So now we can kind of take the next step and just say, how about we connect like all of this to our actual engine, to our actual like scene system and ECS as well, to our entity component system, so that we can, like, once an entity has been created, we can call like an onCreate function. Once, every time an entity gets updated, we can call like an onUpdate function if it's present, and all that kind of stuff. And so that's what we're going to do today. We're kind of going to connect the dots so that we can actually utilize everything we've learned here in a way that ties back into like Hazelnut, and so that, we can hit play and we can see some stuff actually happening. And then the way that we can test this, like the test case that I'm just kind of think we should probably use for this, is maybe going to be, I've got this selected, is maybe going to be like, I don't know, maybe controlling a player or the camera or something. Maybe we can make that happen. I don't want to go too deep into this because like we'll need to probably add a binding for every single action that we might want to do, but that would be kind of cool, right? Because we could maybe, for example, if we wanted to move this square here using like the WASD keys, because it has a rigid body, we'd probably have to tell Box2D how we want that to move. Actually, maybe we should do that today. That'd be kind of cool, I think. I don't think it's too difficult to actually make that happen. through Box 2D. If we go to Scene, where's our Box 2D stuff? We obviously simulate everything in Physics World Step, right? So I think if we had some kind of body, you know, like this, I think we can just easily probably apply some kind of force to it or an impulse. Yeah, something like that. And then it's just going to take this stuff in. That would probably be a nice use case. So let's do that. Let's set that as kind of our goal for today. Let's make it, hopefully, so that we can control our physics 2D scene, right? So that we can actually control our kind of sprite character here using like the WASD keys. Let's make that happen. Okay, so step one. Step one, actually, and what I'm going to do. So if we go to script engine at the moment, you can see that basically the way that it works is we have this kind of, I think we have this area over here inside init. We init mono, we load an assembly, right? And today we're just gonna put everything in Hazel script call. We'll talk about how we can separate like our actual project assembly from like the core, because that's gonna have to happen as well. We'll basically end up kind of loading an assembly for the core kind of Hazel API that's written in C#, which is what Hazel script core is. And then also, you know, loading out kind of game DLL, which will kind of be a per project thing, right? We'll talk about that later. We'll just write everything in here for now. So basically what I want to do is I want to, you know, we'll register the functions, which basically is what registers these kind of internal calls, which sets up our API in the first place so that we can call back into C++. And then you can see we've got a bunch of stuff here that we can use to actually like instantiate classes, right? So this stuff over here already is kind of stuff that you can imagine happening when we actually create like the game and we start running the game. So for example, like in this case, what we're doing is we're creating this Hazel entity class, right? What we'll do is Hazel entity, this is essentially going to be, and in fact this namespace doesn't matter too much either, but this is essentially going to be like our namespace obviously here, and then whatever class we create in C# that's supposed to add the behavior for some kind of entity, right? So in that kind of example that I showed or talked about earlier with the player and the box 2D and moving the player around, we would have some kind of like maybe player script that we create. So let's actually do that now. Let's go ahead and set up a script. It might be easier to kind of do this backwards. So if we make a script called player, the namespace doesn't really matter. Maybe this will be like our kind of sandbox project or something. And then we'll have like public class player. And then what I want to do is I'm just going to create an onCreate function. And I'm going to create an onUpdate function with a time step. So this is identical basically to how it's set up in real Hazel. However, the difference is that like we are a subclass of like entity, which is a Hazel kind of class, which we will eventually do here as well. And also these are kind of virtual functions just so that we can easily override them. They don't need to be, because again, remember, since we're actually running the whole C# like system, the whole C# runtime and virtual machine inside of our C++ thing, we can freely just call these things basically using reflection, right? So we just know that these are functions that are present, and these are classes and types that are present within that DLL that we just loaded. We can just arbitrarily call them however we like, right? Doesn't matter if they're private. They don't need to be like some kind of virtual function that's overridden from the base class. None of that needs to exist. It can all just work, right? Because it's obviously aware of everything since we are the runtime, which is nice. So these are basically the two kind of things. So I want to kind of log this in some form. So for now, we'll just use console write line. Eventually we'll have Hazel logging functions that will appear, you know, more in kind of like a Hazel format like this, instead of just like that. And it'll kind of go into our native logging system that might write to a file and do other stuff. But for now, just because I want to initially test these, we'll just do, you know, player on create. And then we'll do player on update. And I'll actually kind of, maybe I'll use this to just have the time step here as well. So I've got two functions, beautiful. So how do we want to kind of link to this? Because see, this is now where we kind of enter the realm of design. right? Why has this happened? Reload. It's a bit weird. Oh, because it's rerun pre-make probably, because that's what one of these things does. This pre-make thing, I think. Anyway, so how do we actually get to the point where we can, you know, tie this up with our C# or C++ entity system? So again, this is now a design kind of thing. And the way that we're going to make this work, at least for today here, is going to be pretty simple, right? So we have obviously all of these entities in our scene over here. What we can do is we can add a component to them, and we're going to create this new component called a script component. Now, what does that actually mean? Well, initially it could mean nothing, and it's not going to mean much initially, right? The only thing that we're going to specify in that script component is going to be basically this portion here. Because what's happening, right, is at the moment we're creating a script class, and it's coming in from, like, we have a namespace, we have a class name, that all is you know, is there. And then from there, we're able to ask the DLL basically, hey, do you have that? I mean, what happens in script classes, you can see we immediately do monoclass from name. So obviously if we pass something in there that doesn't exist, it's gonna give us null, and that's not gonna work. And then from there, we can obviously instantiate and do whatever we want, you know, with that actual type. So really the only thing we need to do is we need to be like, hey, well, I don't want Hazel entity, I want sandbox player, because that's the script we just wrote. So the way that we're going to set this up initially is we're just going to get the user to, like, type in a name, right? And then hopefully we're going to match with that. So that's actually how Big Hazel used to work. Now we do something a little bit different. We can actually go through, like, you know, all of these assembly types, for example, and then create, like, some kind of list of pre-existing types that we've loaded in. The reason why I don't necessarily want to do it that way, I mean, we could do it that way. Like, if are we calling print assembly types anywhere? Maybe that would make more sense, because then we'd see everything that's present there kind of. I think that actually might make more sense, just because what's going to end up happening is we obviously don't want to specify, like, the namespace and the name of the class separately. So we probably want to write something like hazel.entity, and so, or hazel entity or sandbox player. We probably want to do it that way, right? So because we want to do it that way, it's going to mean that we're going to need to, you know, do some kind of string splitting and probably find the dot and separate it and do all of that stuff. And I feel like if we're going to replace that with a list of existing classes anyway, what's the point, right? So with print assembly types, let's just call that. Once we load this, let's just print assembly types, because I'm just curious to see what's actually going to happen here. And I think that's in the utilities, in the utils namespace, right? And then we have to take in an assembly. So I think it's going to be sdata core assembly. Is that right? Yeah, that does look correct. So if we come over here, yeah, like, we've got all this stuff here. Now, obviously, some of these start with Hazel, which we don't want to bind to those classes, but anything else, we want to. And I think actually the way we could probably dress this up to make it even better is technically we are obviously eventually, just like in Unity, you know, we have like mono behavior in Unity or whatever. In Hazel, we just kind of make our script class as a subclass of, like, Hazel entity, right? And so since we do that, and we can chuck in using Hazel here, because that gives us a ton of really, like, you know, and that's already correct. That gives us a ton of useful functionality, right? So we can easily, for example, ask for the translation of this entity or the transform of the entity, or we can just do that stuff like apply impulse or whatever, and we don't have to do it on a context, because the entity contains, like, a list of functions that we can already call, you know, as if they were part of this class, and that's kind of the point of it, right? So because this is going to be a Hazel entity anyway, eventually, we could dramatically narrow this list down if we just say, well, hey, let's only include classes that are in the binary, and inside, like, our game binary eventually, right? That specifically are Hazel entity subclasses, right? And I've no idea how to find that out, because this just contains a list of existing types. But what we would probably have to do, and I don't know if it's worth doing in here, but what we would have to do, I imagine, is kind of retrieve. I mean, it's not that bad, I think, like performance-wise or whatever. But we'd probably have to actually try and create like a monoclass from name, right? And then check to see, hey, what's that, like, who's the parent of that class, basically. And if it's entity, or if it contains entity somewhere in the hierarchy, then it's fine, right? So we're kind of gonna do that. So let's see. So monoclass. So let's do auto. Well, we'll create a monoclass from it, right? And so class namespace, obviously, like we've got this stuff here. So we've got the namespace, we've got the name. So that's kind of our monoclass. And then I think, like, again, this is all about asking the API and stuff. Which, you know, the thing is, this stuff is eventually going to grow anyway, because we need a whole range of metadata that would be useful to us, right? So that's why, like, I'm not afraid of really doing this at the beginning. This is what happens when we load everything, because we're gonna need this. We're gonna need a whole lot more anyway. But there's going to be, like, there is some kind of, I don't know if it's like, there is subclass of. Right, and then this is probably what we want to use. We want to basically ask it, hey, is this a subclass of that? And I don't know what order this is taken in. So is class C? See, this is what I mean. The mono docs are sometimes annoying. But let's just say if this, let's ask it if this is a subclass of something else, right? So let's get Hazel entity. And obviously we don't have to do this every loop iteration or whatever. This is just a little test. Entity class. Check interfaces. I guess, well, it's not going to be an interface, is it? So I guess it can be false. I don't know. Is subclass. Is entity, I'll say. And let's maybe run this in debug, because I do want to debug some stuff here. Because, like, for example, like, one of the things that I'm not sure about is there was that, like, weird class initially, right? Which I kind of don't really necessarily want to deal with. So this is down here. So we need that core assembly image, which is different from the assembly, so we can probably take in both. Like, this, realistically, I don't know why I'm mutilating this, like, print assembly types thing. This is, let's go into here, and let's call this load assembly classes or something, right? So this will be script engine load assembly classes, make it private. And over here I can just kind of remove this because we're supposed to just use this as a quick utility to print assembly types, so we'll keep it as is maybe. So let's do, instead of print assembly types, we'll do load assembly, and then we'll do load assembly classes. And then coming down here, whoops, load assembly classes, what's wrong with that? No, it's fine. So yeah, let's take a look at that. Assembly is undeclared, so this is going to be, well, in this case, maybe I will go back to that actually, because that way we could load it from any assembly, and that might make more sense because we're going to have multiple possible assemblies. So this will be kind of sdata, our core assembly for now, but then also we are going to need the image. So realistically it stays the same because we provide both of those. I was going to avoid maybe doing them, but that way it's not going to be specific to the core assembly because we probably want it for maybe both. And eventually we'll need it for our app assembly anyway. So that stuff's in. So image, instead of core image, we're going to use this image, and let's just see if that does anything, and if that gives us any of the kind of stuff that we want. So mono assembly is just something that we need to replace here, or add to that list, and then there's mono image as well. Well, we might move these out into like some kind of header file that has everything. Oh, images here. Oh, you can just do mono assembly get image. Oh, well in that case, I guess we don't have to. Is that? I'm assuming that's probably fast enough. Well, then we can just pass in assembly. So let's go back up here. Add in our assembly. Load assembly doesn't take one function. Oh, really? So we have to also clear it from here. All right, so yes, I see what there's like a weird one with no namespace, and then it's got the name being set to module. So like I don't know exactly how that works, but the point is you can see is entities false anyway, so that's fine. Then we've got player. So player should be an entity. Now I don't know if I built script core, so this actually might end up being false. As you can see, it is false. Let's build that, and let's try that again because I have a feeling that I just didn't build it. So that's the module one. So this is player. And it's true, right? So it is an entity. So this is great. This is fantastic because what it means is that I can now, if I wanted to, I can make a list, obviously, now of classes, specifically this instance of script class, right? That contains all of my entities, which is beautiful. So what's going to happen now is inside the script engine data, right, which we know is kind of static and we store it over here, I'm going to make a list. This is C++. Let's make a don't know how we want to do this. We could store it for easy access as an unordered map of string to the actual script class instance. That might actually be kind of nice. Because obviously it's going to be unique. Well, let's do that for now. I just don't know. Because if we store it as a vector, then that's fine. But we might want it to be something that we can, yeah, store like this, I think. So script class. And then script class, do we want to have like a ref to that maybe? I think we probably do. So this is all of our, these are going to be our entity classes, right? So our load assembly classes. So if it is an entity, here's what we're going to do. We're going to basically say entity sdata entity classes. So again, it's called load assembly class, but really it's going to load this kind of stuff. So sdata is entity classes. And then what we're going to do is we're going to make a little pretty version of this string. So we're going to do scd string full name, we'll say. And basically, so full name is going to be one of two things, right? We'll use FMT format for this. So it's either going to be, it depends, because this is possible not to have a namespace, right? So let's just make a full name, and then we'll make a little branch here. So if namespace, and it's kind of annoying that this is, well, yeah, I guess we need to see if it's an empty string or not, which, is there a function in C to see if it's an empty string? Like, I guess still in like 0, right? So we'll say if it doesn't equal 0, then we're gonna set full name equal to FMT format, and it's just gonna be that dot that, right? Kind of what we did here, where it's gonna be namespace and name. Else, if that is, I guess, 0, then maybe it would make sense if we did it the other way around, but whatever. Then we're just gonna set full name to just be name, right? So we can just assign it to name, and that should be good. So now we have a fully kind of qualified name, and that's gonna be what we put into here. And then we're gonna set that equal to a, I think create ref is what we use. Yeah. And then you can see this though does take them in separately. So we'll give it a namespace, and we'll give it a name, and it does take them in as strings, but that's okay. And we'll give it a name. So it's a const std string reference, so it'll just create a new string on the fly. All right, looking good. Looking good. So what I'll do now is, like, we should, I mean, ultimately we should have this here now. This is going to populate it with these things. The first thing I'm actually going to do is just clear this though, because in the future when we reload these assemblies, we're going to want to repopulate them with everything, so it makes sense to clear it first. But yeah, that's kind of it. Now, entity class, yeah, what I'll do is I'll just move this up here. I'm not going to bother like pulling it out for now, but this is just going to be our kind of Hazel entity class. And this is kind of the current class we're iterating through. So yeah. But yeah, that looks pretty good to me. I don't have any issues with that. I think we now should have a proper list of these things. So if we go to like this line of code here, and we just run up until that point, you can see hopefully that in SData, this never works. It's so annoying. Visual Studio, you are the worst sometimes. Let's just execute it again because I can't be bothered. Like ultimately this little section here, but I can't even see it. Okay, let's just, we'll have to work around Visual Studio by just doing auto reference. Classes equals SData entity classes. Thank you. All right. So there's two actually. Oh, right. So Hazel entity also qualifies. That's funny. We can also make sure that we don't load that one. Again, this isn't going to happen because we're not going to be within the repository. The library that has the entity class is not going to be the one that we like load the types for, because we're going to have a core library, Hazel script core, and then we're going to have another one that's going to be like our app. So this won't actually probably happen, but to avoid it, we could easily just say that if, I mean, we could probably do this immediately, right? But basically, once we get this class, actually, we'll just say if mono class equals entity class, continue. Now, I don't actually know realistically if this is gonna work, because I don't know if these are gonna be pointers to the same block. Yeah, they are. Okay, good. So this is equivalent. Okay, cool. So now if we run to here, we only have one class and it's sandbox player, right? This is really, really good because now we can actually kind of create that, which is exciting. So we have all of this extra code here that isn't really used. I'm just gonna put it behind an F0. Like as in, it doesn't do anything, but it's an example of how to use the API. So we've done this step here, right? We just did that. Now we can instantiate the object. Now you can, thank you Campfire Studios for your sub, appreciate it. We could just instantiate it immediately. The reason for that is, and I think that's what we do in Big Hazel. I think the reason for that is because if it's instantiated, then we can kind of already use parts of it and get extra information about it, maybe, instead of instantiating it when we hit play. And because we don't really use the constructor for anything, like it, oh yeah, I think one of the reasons was actually in case you have public fields. So if player, for example, has like a public, you know, float speed and it's set to like 5, you know, you can't really see this value until you instantiate it, I think. Maybe I'm wrong though. What patrons thought we should support here. Thanks, appreciate the support. Yeah, like, I mean, you know, if you want to instantiate it and then see that value, I think I might be wrong, but I'm pretty sure that something like that, like you have to instantiate it so that you can like see that value or whatever, which is why you might want to do that. Again, it doesn't really matter here. So, therefore I'm not gonna like worry about instantiating, non-instantiating. We'll instantiate it like once we have a need to, once we need to do that. Otherwise, like it literally won't do what we want and it won't work. But yeah, that's kind of looking like it for now from here. Obviously, like the easy kind of way to say what we need to do next, if we collapse this, is basically when we actually hit play, we want to obviously load like the onCreate function, which will now be a function from whatever script class we've selected. It's going to be a method called onCreate with like 0 parameters. And then what are we going to do? We're going to invoke it. Yeah. Now, note that there are all of these functions that we already want, right? Using get method. So like we probably don't want to retrieve it all the time. So what we could easily do is we could just say that, okay, once we instantiate it, let's do something else. Let's do a little, you know, instantiate fully. I don't know. No, you know what? I'll call it instantiate. I'll make all this private for now. Or maybe no, I won't make it private. I'll just say create instance and then instantiate. That sucks, doesn't it? I basically want to have like a thing that does like a whole bunch of like setup that sets it up fully, and then one that like specifically only creates the instance. So maybe this will specifically create the instance. I'll just leave it like that for now. Maybe we'll change it later. But the reason why I'm doing this is because this script class, right? I actually want it to, when we do instantiate, I want it to create an instance, and I actually want it to like hold the stuff, right? So this script class ends up being like a script instance. Now I'm beginning to think that, nah, this is dumb. Okay, sorry. I take back everything. I take back the whole thing. So this is going to be instantiated because that's going to be a dumb design, because what I actually wanted to do was I wanted to have script class be something that is like a class, doesn't have anything to do with instances. And then what we can do is we can make a script instance. And this is going to be different, because what this is going to do, and the way this is going to work, right, is we're going to probably take this in with like a script class, right? And it's going to hold state, right? So it's going to have, like, for example, when we call instantiate and it creates a mono object, that's going to have the instance in it, right? And it's also going to have the methods that we need. So it's going to have this onCreate method, we'll call it, and also the onUpdate method, right? So now we can actually call, like, you know, invoke onCreate, invoke onUpdate, for example, with that parameter, and then that will do the work for us. And we only have to provide this, which is great, right? So when we actually create a script instance, this is how it's going to work. When we create a script instance, it's going to automatically instantiate itself, because instantiating this is the same as instantiating the object. That's just how it's going to work. So let's just assign that script class here. And then this is going to call instance equals script class instantiate. So we've instantiated it, but then it's also going to retrieve all the methods for us. So for example, the onCreate method is going to be get method, and then so we get name and parameter count. So let's just call onCreate parameter 0. OnUpdate is going to be called obviously onUpdate with 1 parameter. And I believe if we go back to our test code over here, that's pretty much all there is to it. Yeah, we just say we want that with 1 parameter or whatever. It doesn't really specify any overloads specifically, but we don't really have any at the moment, so it's fine, right? So this isn't like a fully qualified, like it's not the full signature obviously of the method or the function or whatever. And then I guess we probably want to de-instantiate it over here. I don't know if that's necessary, if the garbage collector will just deal with that in the destructor, but we'll see. And then obviously to invoke it, so how do we invoke these functions? Well, if it has 1 parameter, then we just do that. So let's copy that and we'll use that for onUpdate. And obviously if it has 0 parameters, it'll be like the same. So basically we just do script class, invoke method, instance is going to be minstance. We're going to invoke the onUpdate method, and we're going to use that parameter here, which is going to be the time step, which I think we can just set up like that, right? That's it. Easy. Now, obviously this might like throw an exception or whatever. I mean, we might need to handle that, you know, within C# and whatever, but we'll talk about exceptions at a later date. So that's step 1. Obviously the onCreate's even easier. It has no parameters, so we just pass in, I think, null pointer. So where's an example of that? Oh, I think it just has an, yeah, we just don't pass that in, and it will be null pointer by default. So yeah, that's basically it when it comes down to this. What's next, guys? What is next? I think that's enough to get us started. Wait, why is this script instance script class? Oh, I forgot to do that. Whoops. I think that's enough to get us started. The next step is, I think we can actually just create that script component. So the hardest part of the script component, legitimately, is going to be adding like UI for it. So let's create it over here above native script component, because we're not really going to use that much, I think. And then what we'll do is, like, fundamentally in the beginning, this is just going to be like the name, right? But the name, like, we could choose that ourselves, or we could enter it ourselves, but we probably just want to select it from a drop down and maybe even have like a search, right? So this is probably a good opportunity for me to show you guys how Big Hazel handles this, just so that you know what I'm talking about. So let's open up Big Hazel while that's opening up. Let's put a little semicolon here. But yeah, like, you know, we probably should just... we obviously have a list of these. This is script engine. In fact, I can probably just make that something that we can return here. So what's even the type here? I guess it's this. The Cutternet, thank you for the Prime sub. Appreciate the support. Okay, this is Big Hazel, right? So, what am I looking for? So, like, for example, we have like the scene, obviously, that has like some functionality to it, as you can see. So that's coming from the player, and the player, you can see, has a script class of FPS player. And if I click on it, you can see it brings up a list of all of the classes that we have inside this project's like app C# binary, right? So inside this project's like scripts, these are all of the ones that are present. And this is the sandbox project, so it's got a whole bunch of tests and a lot of stuff going on, right? And then you can also be like, oh, I want the FPS player, and you can kind of search for it, and it appears here. So I don't know, maybe I'll just copy this UI, like, and by copy I mean literally copy and paste it from Hazel, because this is kind of nice. I mean, it might not look exactly the same without all the other styling, but something like this is kind of what I'm thinking of having, right? Because that way we can just, I'll probably close it. That way we can just, you know, obviously easily pick something and it won't be a problem at all. Cool. All right, so how do we get started with that? Tell you what, okay, guys, I'll tell you what. We're gonna do it the bare minimum way first, and then if I have time at the end of this, then we'll implement the UI, all right? Otherwise, we might save UI for later, just because I don't know. I don't necessarily like spending a lot of work polishing something when we don't have the basic functionality down, and I would much rather have the actual, you know, entity move and stuff and not have fancy UI. So we'll do the UI at the end if we have time. Okay, so if that's the case, and we have our name here, basically, which is like kind of our name, right? We're just gonna make a little text field that's gonna let us type anything in here. Now we're just gonna add in like the constructor and copy constructor. This is not really necessary, but I like to do it as well, just because you really need to provide a proper copy constructor for all of these component types. If you don't, like, the engine won't work properly. Now, in this case, obviously the default copy constructor will do a copy of this string, and that will invoke the string copy constructor, and everything will work fine. So that's fine, but I just leave these here even though they're not required, just as like a little, you know, just to make it more clear. All right, so script component. So let's go ahead and go into our scene hierarchy panel. And over here, we can basically add in all of our component stuff. Now we added a new component, so we also need to make sure that we put it here. So let's kind of shift these down maybe. We need to make sure we add it here to our all components list. Very important. Speaking of things that will make the engine not work. And then what we're going to do is if we go into scene hierarchy panel, yeah, that's probably where I want to be. We basically need to, I mean, draw components. Yeah, we'll need to do like display add a component entry, for example, for that. So we don't have a native script component here at all. But let's just add it over here. I don't know. The order of this is a bit weird. Scripts are pretty important. So I do want to have them pretty high in general. But if we search for every, like, if we just search for camera component, we can kind of see what we need to fill out. I think it's just that. And then also we want to obviously draw stuff for it. So I'll copy like draw circle render component because it's just a bit easier to deal with. And I'll probably put it maybe under the camera component. And this is going to obviously be our draw component, script component. We're going to call it script. Entity will be there. Component will be here. Now, kind of the only thing I want to do here, and this is what we're going to do. We'll implement it in kind of like the old school case maybe, but ultimately like we could give a drop down or some kind of searchable list of all possible classes because we already know what they are. But I'm going to do something else a little bit worse and weirder here. I'm going to basically just say that we're going to have like a text edit, which, what's it called? Input text, I think. Yes, it came to me. Input text, script. I'll just say class. Okay, and then how's this gonna work? So basically we're gonna have a little char called a buffer. Maybe like 64 characters or something. We can probably need to like initialize that. And make it static. So we'll have a little buffer for this. Wasn't there like some kind of function for this? It's not set string or something. It's. I'm gonna just have a look. Where's like the C++ reference or whatever? Ugh. I remember something else. Alright, whatever. Let's just do a mem set. Okay, so we'll do a little oh, but we need to do that obviously the first iteration. Oh, well actually, no. I think I think if I just do a string copy into there, it will add the null termination character. So actually I don't need to do anything that I just said. Okay, so let's copy in basically anything that's already set there. So in this case, this is going to be from the component. We're going to copy in component dot, why are you annoying? Dot name dot cstring, which should just be null initially. That's going to be what we have here. Buffer, buffer size 64, which I guess we can do size of buffer because it's chars. And then flags, yeah, whatever, we don't need any of that. And then if we do change it though, we need to handle that. Maybe that will work. So if we handle that, first of all, we need to set component name to buffer. And then the thing that I want to kind of do is I want to validate it and make sure it's actually a real entity, right? So I'm pretty sure that there's no way to detect when we, well, no, I guess we can, when we unfocus it or something, we could probably check, right? So I didn't finish with this, but I'll just say get entity classes. Make it static. Don't know if I'll actually end up using this. No, I think I will. So that's that. Get rid of all the Hazel. Namespaces F5. Okay, so script class is not a thing here. It's a bit annoying. We can just move this up. I think we should probably move all of this stuff up. We'll probably move them into different files, I think. There's no real reason for them to be there. Okay, overloaded function differs from, I guess, something else. Script class instantiate, does it? Oh, there's two of them? No, there shouldn't be any more. Why are you saying there's two of them? What? Oh, or have I... Hazel script class instantiate. Oh, sorry, I forgot the mono object. Okay, invoke method. And you're upset because it's not a member of that. Static assertion failed, and that's probably because we're missing this stupid thing, which we have to add for script component. All right, F5. Should finally be able to run this now, and maybe not. Oh, I tried to instantiate a class. Okay, let's not do that. I think that's... Wait, actually, why? Oh, because I just put this here. Okay, yeah, let's not do that. That was just some test code. Okay, so now if we go to like physics 2D and we go to like, you know, this thing, we can add obviously a script component, and then the idea is we're going to be able to type something in here. So again, you know, eventually we'll have better UI for selecting something instead of just typing and maybe even dragging, you know, all of our scripts from here into here or whatever. But for now, we'll just, basically the expected thing to type here is going to be sandbox.player. And then if you type that in and that's all good and you've finished editing that, then good. Then it can validate it or whatever. You could also validate it while you type. So every time you make a change, like here, you can just ask the script engine if it contains something like that. So that's kind of what I'll do here. I'll just show you guys how to set that up. And then of course you can do whatever you want. So script engine, get entity classes. So const auto entity classes. And we're just going to say if entity classes dot find, you know, a string that we've typed in here. So component name, we actually might do it outside of this, but if entity classes dot find component name doesn't equal entity classes, or rather equals entity classes dot end, then that's kind of a not valid state. Now we could do it outside of this. I don't know if I want to do this every frame necessarily. I mean, it's just a map check actually. I forgot it wasn't hitting the thing. So let's do it out here then. Because what I'm going to do is I'm going to just modify the color. This is actually exactly how it used to work back in the day in Big Hazel, which is kind of cool. But basically, yeah, if we're trying to find this here and it's not here, then we'll make a little bool exists. I'll say script class exists, false, true, if it finds it. So if it doesn't equal end. And then if it doesn't find it, I'm going to do basically if not exists, then we're going to do IamGUI push style color. And we're going to do IamGUI color text. And we're going to push on like an IamVec4. We're basically going to make it like red. So we'll do 0.9 0.2, 0.3 or something. And then obviously we'll do a little pop as well. So this should be pretty cool. What on earth are you guys talking about in the chat? Okay, that's... Why are you upset at that? That seems legit. I might have to include it actually. So Hazel, scripting, script engine. Alright, I think we're good. Alright, so if we add script, oh, I made this red. Oh no, it's gonna make everything red. Okay, cool. So you can see it's red now, right? And then if I type in, what is it? The magic words, which is sandbox.player. Hey, it's not, right? So that's pretty cool. So we have a way to obviously set a valid class here now. And now the next step's gonna be when we hit play, I want all of the script components inside our like level to work, to actually trigger that onCreate function and be instantiated. What I'll quickly do though is I'll add this to our serializer so that we don't have to keep re-adding the script component every time, because obviously we didn't make this for it. So we need to make sure that we do that. So this is an entirely new component. So I think we'll just copy and paste this and this. And then the key, really the only thing we're gonna have here. Let's just do this quickly. Is going to be the class name. Or the class as we called it. And that's going to be a... we need to get the component. Hey, thanks for the sub, Wayne. Appreciate it. 5 months. Thank you. I've actually just called it name. Let's call it like class name or something. That might be better. Okay, so that's the, what is this? This is the serialization, and then we have to do the deserialization as well, which is down here. So we'll add the script component, SC, and then we'll do class name. Never gives me IntelliSense for this stuff. Is script components, class name, string. So we'll just start as a string for now, obviously. And then later it might be something more sophisticated. Okay, cool. So now, yeah, Control S should basically work for that, and it should be able to serialize and deserialize properly. What do we want to do next? I think when we hit play, so if we go to scene. No, wow, we don't even have a, oh yeah, on runtime start. So this is on runtime start, right? So we have on physics 2D start, and that starts our physics so that it does stuff. We need to basically on runtime start scripts, right? So this is going to be a script engine on runtime start, basically. Now, here's the thing, I'll let you guys in on a little secret. When we do on runtime start, we overwhelmingly are going to need to access the scene, right? I mean, a lot of the stuff that's done inside C# as part of our scripting is us kind of manipulating the scene. It's like, you know, modifying components, modifying like our translation and stuff. And where is all that data stored? Where are all of the entities stored? In the scene. So it's going to need the scene. So usually what we do is on runtime start, we want to kind of give it access to the current scene. Now we have a bit of a predicament here though, because I don't really want to pass this as just a raw pointer. I prefer to pass this as like a ref, right? Which at the moment, refs are just shared pointers, and because we're not using intrusive reference counting, it means we can't actually create a shared pointer from this. So we can't just do scene or whatever equals this. That's not right. I mean, it will let us do that, but that's wrong because we're not actually increasing the reference count, or rather we're not accessing the same instance of the reference counted object. So for now, we'll probably pass it as a pointer, but in the future, we're gonna change this to be our own intrusive reference counting system like it is in Big Hazel, and then we'll be able to convert this into essentially a shared pointer, which is going to be very important. So we'll just do scene for now, and that's going to basically be our context, right? So if we create this, we're going to do sdata current scene, I'll just say scene context. And then we'll also add an on runtime stop, we might as well. This doesn't need any context, but this will clear it to null pointer. And then obviously scene context is going to be, if we find our data, up here. So again, that's going to be important because we're going to have to interact with the scene through our scripting. And that's how we're going to do it. Okay, cool. Coolsies. So we'll just add in that on runtime stop. And see, on runtime start, this is going to be an important thing here because we're going to have to actually go through and start the scripting. So what I'll do actually is, I mean, I could do it from there, but I don't really want to because it's going to be a lot to do with the entity component system. So here's what's going to happen. We're going to, the same way that we had this kind of on physics start and stop, we'll say on scripting, maybe start, stop. It sounds a bit weird, doesn't it? What do we call this? Well, whatever. You know what? I'm sick of creating functions for everything. Let's just do it all in here. So we're going to do on runtime start like that. And then we're going to have to instantiate all script entities, right? So this is where we're going to basically go through. So we'll call this section scripting. We're going to go through here and we're going to basically grab a view of all of the scripts in our scene. So we'll do script component. I'm going to go through all of these and let's grab some extra code. So we'll create entity from it. e.get component, script component. So we can grab that as a const auto script component. And then obviously if sc dot class name, if that exists, right? So here's the thing, script engine class exists. We're gonna make a function for that just so that we don't have to deal with that manually every time. So static bool class exists. Full name, maybe full class name. When I write full class name, by the way, in case it's not obvious, that means basically including the namespace, so like the fully qualified kind of name. So, and then this will just return as data entity classes. So this is more of an entity class, right? So I'll say entity class exists because this is specifically gonna only search classes that are a subclass from a subclass from entity. Is the stream laggy? Why is it laggy? Should be okay. Dropping frames. Not according to this. That's a bit weird. No, I don't know. Shouldn't be laggy. both Streamlabs OBS and Twitch are saying it's great. So that's a little weird. Oh no, hang on a minute. No, I am dropping frames. What? This could be just the internet being garbage. Sometimes it's garbage. Okay, now it's better, I think. It's weird. Anyway, the recording on YouTube will be fine. Okay, so entity classes. So yeah, this only checks obviously like classes that are specifically subclasses of entity. Browser28, thank you for the Prime sub. Appreciate the support. Okay, so s.entity classes.find full class name doesn't equal end. So now that we've done that, we can also go back to scene hierarchy panel, and instead of trying to do this here and retrieving them and doing all of this stuff, we can just say entity class exists this, right? So basically script class exists now just becomes entity class exists component name. So that makes this a bit cleaner. There you go. Yeah, I'm in Australia, hence the drops. Hence the frame drops. They should be stabilized now though. Okay, so let's see. Where were we? So if sc.class, so now we just do this basically. If script engine entity class exists and it's going to be sc.class name, right? Then we can instantiate it. So how do we do that? Well, I mean, ultimately we can probably just say create entity instance. So, or maybe on, I don't know, on create entity or something. And this is really going to do two things, right? It's going to basically, and again, this is like, it kind of depends like how you want to do this. I think maybe you could even do on create entity and you could actually pass in the entity and then do that internally. I think we might do it like that. So we'll keep it a little bit more abstract because the script engine should be doing all these checks anyway. So script engine will do void on create entity. And there's a lot of like different ways you could architect this, obviously. Like you could make it so the script engine is generic, doesn't even know anything about entities or the entity component system, which probably would be a decent way to do it, but I'm not going to do it that way. So we'll just get the script component. So in other words, this will be aware of the entity. So if entity class exists, so we'll do script engine class name as we did there as well. This is where we actually instantiate it. So we don't have this here, do we? We have entity classes. I want to also create entity instances. Now this is a bit different, right? Obviously every entity is only allowed to have one instance of a script. Meaning like when an entity just maps to a script instance. Like when you hit play, you have a certain class attached to it, it gets instantiated, you have your script instance. So this is actually like per entity. Whereas entity classes, that's just, obviously you can have like, you know, maybe every enemy in your game has the enemy class, and that's, you know, you might have 500 of them, so you have 500 instances, but just the one class. Because class is like the actual class that you've written in C#, not an instance of it. So this, in other words, is going to be different. So what we'll do is we'll have a map here of UUID, which is going to be entity, to an actual script instance. That's going to be cool because that means that if we want to update a particular entity by its UUID, we just look up this map and we have an instance of it here, presumably. So that's what entity instances is going to be. And so what we'll do when we actually create this, right? So we do, what is it? Create on create entity. If the entity class exists, and that's, you know, present there, then we can actually do ultimately entity instances, and we'll get the UUID from this entity. So get UUID equals, and this is obviously S data, equals a new instance, so create ref of our script instance class. And what does that take? Just the class, I think, right? So we'll grab, since we know that exists, I'll just drop it down. It's going to be entity classes, SC class name. Okay. And I think Control F7. Why does it not compile this file for me? Control F7 doesn't work. Why? Are you confused? Is this actually not included in like compilation or something? It is. Maybe I should add and remove my compile button. All right, whatever. Let's just build Hazel. Okay, so many errors. So scene is not aware of scene. Now, do I want it to be aware of scene? Probably not, because script engine might be there. So I might just forward declare it. We'll just write class scene. Entity is also not here. The problem with entity, though, I mean, I'm sure this will work for now. Let's just include scene in this. This might be a mistake, and we might go back on this later. But for now, we'll do that. Just because entity is gonna include components, and that'll be like a problem basically. All right. What's this? Entity. It's still upset about entity. I guess that doesn't include that. On runtime stop, not a member. Script engine is not a class on this. Okay, so we're in a CPP file here, so we'll just add in Hazel scripting script engine. Okay, cool. So yeah, basically now this should kind of work. We'll just create a ref here, and obviously that will instantiate it, right? And that retrieves all of this stuff, instantiates the entity, and then we can invoke on create. So let's do that. So once we've done that, so here's what we'll do. We'll basically grab a ref of script instance. That'll be our instance. We'll add it into this list, obviously. And then we'll call instance on create, or invoke on create. Why are you so difficult? And that's it. Yeah, so hopefully that makes sense. If I hit F5 on that, so what we've got at the moment, I'll fix the compiler in a minute, is basically just remember player on create. So if I've done this correctly, then we'll be able to just hit, let me build this as well. We'll be able to hit play and we'll see player on create get fired, hopefully. Now, what were the build errors, or were there any? Maybe a linking error or name. Yeah, so this is called class name. All right, because this is inside this is inside the editor. Okay, let's do it. So scenes physics 2D, and then if I hit play, if we go over here, yeah, that did not. Oh right, I didn't add the script component because I didn't save it last time. So sprite is our kind of player character here. We'll add component script. We'll type in sandbox.player, right? We'll hit Control S to save it. We'll hit play, and then we get a crash, which is exactly what I wanted. So invoke on create. So what's your problem? So on update seems to be there. MS seems to be there. That's sandbox player. Oh, on update. That's wrong. Sorry, that was just a copy paste error. I wanted to obviously call on create. It was probably upset because of the lack of parameters, because they were just set to null pointer. Okay, so again, our serialization worked. Play and check that out. Player on create. Amazing, right? So now that works. And the cool thing is you can imagine that to update it, it's really not any harder. We just invoke on update. So we have on create entity, let's make it on update entity, right? And we'll take in obviously a time step. We'll create that implementation, and again, it's going to do basically the same thing. Now, we probably don't need to worry about entity class exists and stuff like that. This is different. This was us adding it to this thing. It's now in entity instances, which by the way, brings me down to the fact that we should definitely clear that when we stop. So on runtime stop, we'll set that to null pointer, and we'll clear all of these instances, right? So that's very important. Otherwise, we'll have an ever-growing list of instances. Ever-growing map of instances. Okay, so on update entity, we'll invoke on update, but we'll get it from this thing. So what we'll do is we'll basically, I mean, at this point it should be here. We should never be updating something that's not here. Entities can obviously get destroyed during runtime, but that when they get destroyed, they should be removed immediately from this list, from this map. So in other words, what I'll do is I'll just throw in a little core assert just to make sure that entity instances.find add entity get UUID is not end, because it should be there. Right, so that's there now. And then maybe I'll do UUID entity UUID just so that we grab that out. Because we'll access it here, and then ref script instance, and then we just do instance invoke on update. Now on update, obviously it's going to take in that time step, but otherwise that's basically it. So that's updating entities. So now if we go back to player, sorry, not player, scene, we'll copy this, and we'll come down into on update runtime. So update scripts, we have our native scripts here, right? But really, because we're not really even using them that much. So we'll do, okay, so this is a different for each kind of loop. I don't know which one is better really. I like to just do them that way, I think, to be completely honest, instead of a lambda. So let's get rid of this, let's get rid of that, and we'll do C# entity on update. That way it's nicely searchable. If someone types in like on update entity or whatever, they can find it here. And then we'll go through and we'll do on update entity with that time step. Now this time step might take in this way, just because that tends to be how we take in time steps. But in this case, if we could just cast it to a float, it should be an implicit cast anyway, and it should be okay. So on update entity, we'll pass in that time step, and that's like it, right? So this is all very easy, as you can see. So now if I hit F5, remember we were printing inside player, we were printing on update here with the actual frame time here, with the time steps. So if we go to scenes, physics 2D, hit play, there you go. We've got that on update running, and we've got the time step, and it's all coming from C# obviously, which is amazing, right? Really cool. So now what I want to do is I want to talk a little bit about how we're going to set up the API for C#. So this is going to be a big task, but we're going to smash this out in some live stream at some point, obviously. But basically what we need to do now, like we have a way to call everything. I mean, not everything, we've just got on create and on update, but you can easily fill in the blanks in your own projects, obviously, if you want. But basically the next step is to create like an API for us to actually like do things with. And this is a really important thing to do, right? Because, and this is actually going to be a little bit challenging in certain ways, because part of the way that we probably want to interact with C++, like there's a lot of room for optimizations, and there's also like the design and architecture of this is kind of important. So it's not just about necessarily binding like to C++ and doing stuff. Like we might want to kind of, you know, obviously keep some context in C# land. So what I mean is like, we could obviously kind of almost procedurally write all these things like, you know, rigid body dot add impulse or whatever, and then that could add an impulse, and in a way, like we need to obviously be aware of the current entity where we're applying the impulse to. So maybe it was even like just add impulse, and then like, you know, new vector 3, and we could add our impulse and everything will be great, right? But we probably want to be able to do stuff like rigid body, you know, 2D component or whatever, just rigid body 2D. And then something like get component, you know, rigid body 2D, right? And then this is like a whole thing now, because we have these types that are actually part of the C# type system, but they represent C++ types, right? So it's like, it's this whole kind of connection. And that's definitely going to be a topic for another day. So I think what we'll do today is, instead of doing that kind of rigid body impulse thing, we're just going to control like the translation of an entity, hopefully through this player thing. So for that to happen, the way that I would like it to work, at least for today, is basically let's grab the current translation, which will just make it happen like this. Let's kind of mutate that state a bit. So we'll say translation.x, for example. Well, we'll have to read like key inputs. So maybe translation x. Well, let's just say translation x ++ or something. Plus equals maybe some kind of speed. So this is your like really basic thing here. And then we'll just say translation equals translation. So we'll assign it back. And we'll have to do it this way because these are value structs. So, so how do we do that now? Well, so the first step here is translation. So entity is obviously this kind of base class, and we added a whole bunch of junk to it last time, but we're going to get rid of that now. And all of this stuff is really, we're going to get rid of all of it. And then we're just going to add in this kind of public vector 3 translation. And this is going to obviously have getters and setters here. So, right, stop doing that. Get and set. And we have our internal calls here, which again, for now are here, but it's okay. So we have ones that actually deal with a vector, which is very useful, and ones that output a vector. So we're gonna kind of duplicate this one. These are gonna be our real ones. And we're gonna have entity translation, right? Entity translation, we'll say get translation and set translation. Get translation is just gonna take in a ref parameter like this, and it's gonna give us back a translation. Sorry, so this will be an out actually. And then set translation is gonna take in a translation like this, and it's gonna set it. So then now we just need to basically call entity get translation. So this will basically say, just return, or rather, vector 3 translate, let's do this, out vector 3 translation, return translation. And this is obviously in the internal calls class here. So internal calls entity get translation, then return translation. And then similarly, we'll just do a ref value for set translation. Okay, so that's our getter and setter for translation. Pretty basic. We just need to provide these functions now. And this is going to be really interesting because like we're going to create this whole thing, right? Because none of this infrastructure exists. Like it might seem simple because I've just written half of it, but actually this isn't going to work, and we're going to make it work by adding all of the stuff that we need for it, which is a great time to kind of introduce this stuff, right? So how do we set a translation for a particular entity? Well, when this calls back into C++, I mean, let's see what happens. So let's go into our script glue like we did last time, right? We have all of our functions here. And let's make functions for, so we'll say, I mean, what are these even called? So entity get translation, and then entity set translation. So get translation will kind of take in our this will be our out translation. So we'll just say out translation, right? And then we also have one for set translation, which will obviously take in a translation. that's cool, bro, but where's my entity? Right? Like, what do we actually do here? Because we don't have an entity. We have no idea which entity has just asked for its translation. Therefore, how are we going to get its translation? Like, that doesn't work. So that's an important kind of point here. How do we know what translation to get? Now, the cool thing is we do actually know what scene we're part of, right? So at the moment it's a scene pointer, because we can ask the script engine at this point to give us its context, right? So get scene context. And I'll just make script glue, I guess, well, no, because this is going to be per function thing. So let's just make this public because it doesn't really matter. We're going to make, we have this kind of area here where we just retrieve stuff. So let's also make something here called get scene context. And obviously this will be null if we're not running, but since we are running, obviously this is the runtime, we're going to have a scene context, so we can just return sdata scene context. So we have a scene context. That's actually really easy to get. So we've got access to like the entity component system, but the problem is we don't know which entity has asked for it. So we've got the data, we just don't have the data for that particular entity. And that is a problem. Now what we would want to do, right, is we would like to take in like the UUID of the entity here. Right, like that would be ideal. But how do we do that? Well, to do that, we obviously need to provide the UUID here. So we need to have some kind of UUID, which will be a ulong in this case, for like our actual entity. But how do we provide that? How do we know which entity is asking for its translation? And now we come back full circle, hopefully, to script engine when we created the entity. When we created the entity, we obviously know its UUID. So why not just provide C# with that ID so that when we create the C# entity ID object, we now understand like what entity we've just created, what it's linked to in terms of like its native UUID, right? And then we can access it. We could even give it like the ent ID from entity, the entity component system library we're using. But I think the UUID is just going to be a more universal thing that will just be better anyway. So that's kind of how we're going to do it. So back in entity, because we're actually creating this, right? What I want to do, and again, there's a lot of different ways you could do this. Like we could just add like a set UUID function or something if we wanted to. I don't even know how exactly we do this in Hazel, to be completely honest. We could just take a look at like a script or something that's inside Hazel. Oh, actually, in Hazel script core, let me just take a look quickly. We have scene, we have entity. Yeah, so we do have a constructor, right? If we just take a look quickly at Big Hazel's entity class, there is a constructor here. You can see that takes in a ulong, which is its ID, and then it assigns it to like a field, right? It's a public reader and the ulong. So, and then apparently there's also a way to create kind of this, but usually I think this is what's invoked. So let's kind of do that as well. And I guess we'll make it internal, meaning only to this binary. It could be private as well. I guess private, I don't know, because we shouldn't be creating these from C# anyway. I'll just say ID, it doesn't have to be UUID. And I might call this entity ID so it's clear it's the ID of the entity and not the component or something. And then we'll do, so yeah, I guess we'll just do we'll do the same thing. So we'll do public ulong, public read only ulong ID, right? And that will be assigned in the constructor. And then if we go back into script engine, obviously to instantiate the entity, as we do here, I think, right, we're gonna have to instantiate it with a parameter now, because instantiate class will do mono runtime object init, but which will instantiate it, but apparently like that's going to call the constructor, but we need to be able to call the constructor with an actual parameter. So this is where I'm probably going to have to consult our like Hazel script engine, because that obviously does that calls the parameter, like that calls the constructor without any parameters, but we have a parameter now. So let's see how we can actually kind of create it, I guess. So let's have a look. So this is Big Hazel. I'm just looking through all of this stuff. Where would this be? Runtime initialize script engine, a script entity, for example, maybe on entity create, that's a method thunk thing. Entity on create gets invoked, and entity object get referenced object, but that's already an existing object. So how do we exactly instantiate it? This looks like a useful class. On entity create. Yeah, that's just methods though. Maybe it's initialize script entity. This looks familiar, yeah. Create managed object. Okay, so that's the constructor. Oh, right, okay. So you just have to call that. And then that calls... Right, okay. So we just call it like a thing, I guess. I think that's correct. Okay. Thanks, iNav23ABC. Glad you've been enjoying my videos. Okay, so yeah, I think long story short is for like an entity specifically, we can just get the constructor and call it specifically, right? So the way that would work is inside onCreate. I believe what we can do, like we already have onCreate on update, and we know this is for a script instance specifically for that, right? So we can actually grab the constructor. Let's grab that. So this is going to be this is going to be the specific one with the UUID. So we'll grab that constructor, which will be, I think, just that, right? And it's going to have one parameter. And then when we do instantiate, which we've actually done that already. I think with script instance, we need to actually grab maybe script class and then the entity like that. And then we can basically do script class invoke method instance constructor, and then the params will be get UID. Okay, cool. That's how we'll do it. Yeah, that probably will work, hopefully. If I've done that correctly, which I don't know about the dot and stuff, but we'll see. Maybe that will work. And the way we can make sure that it works is, so I think, yeah, I'm pretty sure we also need a default constructor. So protected entity, that's what was there. Whoa, go away. What is all of that stuff? Scary. ID equals 0. Okay, and then here we obviously basically grab the ID from the entity, right? That's the thing that we pass in to these functions that now take in that ulong and everything, which means also that inside script engine, or inside script glue rather, inside this place over here, these functions now need to also take in like a UUID. Now a UUID, obviously fundamentally in C++, it's just a UN6, we've made it a UN64T. So that's why like there's no need to take in a UN64T because the memory is identical. So we can just take in a UUID like this and everything's fine. Right, we'll call this entity ID. And for now we won't do anything. I just want to make sure we can get the UUID like to the script first. So actually one of the ways we'll test that is on create. I actually want to do console write line player on create. And then I'll have ID so that we can actually read that entity ID basically. Okay, so UID is undeclared identifier. Include Hazel, was it core UID? And also argument 3 from void pointer to something else. We just need to pass that like that. Yeah, thanks, Aver. You got that right. What's your problem? Create ref with the wrong thing. Yeah, so we need the entity to be passed in as well now, which we'll do here. And we're good. Okay, so what are we doing here? Let's hit play. Oof. Beautiful. Yeah, we definitely didn't get anything. That's still like, did I build that? Maybe I didn't build it. I think I didn't build it. I always forget to build it. Because that stuff shouldn't be there anymore. Although, are we still invoking it? Hopefully not. Okay, still an error. Let's see where that's happening from. So on create entity is doing stuff, and I guess it's doing invoke method, and it's trying to invoke the constructor, which is null. Okay, so it didn't successfully retrieve the constructor. That's cool. Might have to look into some stuff. The thing is though, so get method, what is that? That just does, yeah, that just takes in name.cstring. I thought it was .ctr like that. Looking through some stuff. Yeah, I don't know. Let's try it without that. But I'm not sure. Because the other thing that is a bit complicated here, yeah, it's still null. The other thing that's a bit complicated here is because it's not technically a function on player, right? It's on entity, and I'm not sure if that matters, like. Because we kind of want to create this, but with that, you know? So that might... Okay, looks like we have some... That's not really very helpful. Yeah. I just don't know if that's the right way to do it. It seems to be though. But the problem is, to get that, right? Like, is that fine to do? If like, I'm not even sure if that would work. Because what I'm kind of trying to do is, like, if I create, you know, if I create new player, like, is that even gonna work? So that does work. I mean, I'm within player though. Let's move this out. Does that work? No, it does. But shouldn't that have been protected? Or does this have a default constructor implicitly? Because the thing is, like, this doesn't, that doesn't make sense, you know? Because that clearly doesn't contain a constructor that, so therefore, like, from mono, maybe that's why I can't get it. But obviously, like, that's kind of what we do. Like, we somehow make it work, though. Hey, Peter's here. Right on time. I'm trying to call a constructor. I'm trying to basically, I've made an entity class with this internal, well, with this constructor that takes in a ulong, which is the ID. But how do I create like a new player instance and then call this? I mean, should I then, because if I ask the player script class to have a constructor, I guess it's just can't find it because that makes sense. It's not there. So do I have to ask the entity class for that constructor and then invoke it on the player? Maybe that's right. What if I do, because I have the entity class, right? It's like s data entity class. What if I get the constructor from there? Or is that seems a bit weird as well. But I'm invoking it on the player instance, so that does make sense. Let's try it like that. I mean, is entity class still coming from somewhere? Ah, Peter says yes. Ah, okay. That's not going to instantiate it though, I think. So that's actually fine. You need to get it from the parent. Okay, cool. Thanks, Peter. I think that's exactly what... Yeah. Okay, cool. So then I just do that in this case, something like that. And then if I run this, okay, yeah, it's not null and it seems to work. Okay, cool. So if we go up, maybe we'll have the UID, hopefully. And yeah, that looks pretty good. So now we have the UUID inside C#, and when we try and, like, for example, modify the translation of an entity, we can just pass in that ID, and then that will take us back currently into script glue, where we have all of this stuff, right? So here is our get translation, set translation. So how do we deal with that? So I shouldn't have deleted that thing that I deleted. I want to just copy it, go back to the past, copy it, go back to the present, paste it. Nice trick. So we have the scene context, which is important, but we also have the entity ID. And guess what, guys? Because of the design of our entity class, where it just really is a handle and a scene pointer, we can just do entity equals entity ID. Oh no, we can't. I was getting excited. We have to do, there's one more step. So there should be a get entity by UUID, right? Or just maybe get entity. We can do that ourselves. I was gonna say we can create it from the UUID and from the scene pointer, but the UUID is not the entity ID. So if we go to the scene class, we'll quickly add a function here. It's not what I meant to click, but oh well. Oh, there it is. I'm gonna get rid of you. We'll call it get entity by UUID. I'll be explicit. Whoops. So this will, I don't know if we have a map of UUIDs. We definitely should. I guess we don't. Because this is now where UUIDs are actually going to be useful, probably for the first time when it comes to, oh, we do have that here. Probably for the first time when it comes to having this here. Look, we actually create a UUID map, but it's just a local variable, and we use it to copy components, I think. So we have this like ent map. This is important though, because what this is a map between UUIDs and the actual entity component system. So let's copy this because we're going to need one of these, and we'll call it entity map. We can leave that one intact, that's fine. But basically the way this works is when we, so get entity by UUID, what we just created, that basically just if entity map dot find UUID, we can do an assert here if we want, but because it really should never be null. But I guess I'll just do it like that. So we'll return basically just entity map dot at UUID and this. Otherwise we'll return that. So we can do a little check. Again, this maybe should be an assert. I'll just leave a little to do there. But ultimately, like, we need to obviously populate the entity map with stuff. So, how should we do this? So I guess, and this is really only useful for, well, might be useful for the editor as well, right? I mean, when we create an entity and we do create an entity with UUID, it's pretty easy to obviously just put it into that thing, right? Because it's got a UUID. So before we return it, we can just do entity map UUID equals entity. Well, actually, we need the entity ID really, because we don't care about that, but it's going to be whatever's on this. So entity dot, I think ID, or probably some implicit cast or whatever. It's because it's entity handle. Can we not just get the handle? That's a bit annoying. Oh no, we can. It's just an implicit operator. Yeah, okay, sure. So in other words, that. So we'll add it to the map. And then obviously here, we destroy it from the map. So erase entity, like that. Okay, script clues upset about scene being undeclared, or whatever. Entity's not here either. Okay, so this is get entity by UUID, and then we type in the entity ID. Now we have the actual full-on entity. So we can obviously easily just say entity dot, do we have a, yeah, translate, no, wait. I was gonna say, do we have a transform component shortcut? No. Okay, so get component, transform component dot translation equals, oh, this is get translation. So our translation equals, so we'll copy that data there. So we can get the scene, we can get the entity, and then we can do the out translation. Same story, obviously, for here. We just set it instead. So translation equals, we'll dereference it and copy that data in. Okay, easy. Now that we have that kind of get entity by UID thing as well. So that's kind of all there is to it, I think. If I go to, where was I going to make sure that it was working? I guess that's it though. So at the moment, the functionality we've got is just translation plus equals speed. Let's actually multiply that by the time step. Let's build this binary. And then what we'll do is back in here. Well, let's launch it. I think we'll just, because the problem is at the moment our scene, I want to do quite a bit of work apparently before we launch it. Oops. Get scene context not found, really. Really. Get scene context. But it's here. Why are you not working? Do you need the script engine here? I guess you do. Ah, okay, let's see. Wait, what? I keep forgetting what this is. Yeah, it's an entity. Oh, wait. That's what we want, because it's by UID, that map. All right, cool. Pretty cool. All right, now we get a memory free thing. What the heck is this? Oh no. All right, guys. I think we just corrupted some memory. And it was going so well. Why is this happening now? Oh, how did we do that? I didn't even add anything dangerous, I thought. Seb and CGI, thanks for the Prime sub. Appreciate the support. Guys, how did we corrupt memory? Let's end it here. I would like to, actually. I'm pretty tired, but I should probably fix this. Because then it's actually working. As soon as we fix this memory corruption. How did I even do that? What happened? I don't get that. Because none of the stuff we've written has even been called yet. Ah, whatever. Nah, it's very upset. Ugh. Okay, what did we just do? Because we're not calling that stuff. Realistically, the only thing I added, I'm pretty sure, was this and this. Like, that's the only stuff that probably ran. In fact, create entity with UUID. That probably is not even running yet. Because I don't think we've created any entities yet. I just added it here. What else did I do? Because none of this stuff is happening as far as I'm aware. Well, we're doing this and stuff, but... Wait, this has a default constructor, right? Yeah, that's fine. Script component? Nah, that's a string. Script component is just a string. What is happening? Let's just do a clean build. Yeah, I can I'll open up Fork, I guess, and see what I could have done, but that's bizarre. That is bizarre. Okay, that's fine. Because we're not really running any of this code yet. Well, we added a bunch of stuff today. It's not even rendering this, so that's not running. Barely anything, like it's like on engine startup, like, and nothing's even running really. I mean, we would have initialized the script engine, so it might be something that we've done inside one of these functions. But like, you know, it's not like we're doing some low level stuff. Oh, now it works. Are you joking? I hate you sometimes, everything. All right, cool. So this is our actual stuff not working. So how's component transform component? Is this? Okay, so maybe this didn't work. Oh, well, MScene is null. Oh, MScene is null. Wait, what? Oh, so we didn't find it. So it was, oh, because I commented out the stuff. Okay, let's add this back. Yeah, sometimes you just need a clean build. Okay, so if we hit play, okay, it works, great. So it's trying to probably move our entity, but remember, this is a physics rigid body, so it's being simulated by physics. So that's why it's not really working. If we go into like something else, like pink cube, and maybe we want this right guy to move, we can just add a script component to that. We can add our sandbox.player thing, and then, whoops, player. Then if we hit play, see ya, there it goes, right? So you can see that our script is in fact working, and we're obviously controlling that through C#, which is pretty cool. Now let's make it a little bit more fun. Let's make it be like the WASD keys, and then we'll end for tonight. So instead of just doing this, obviously for that to work, we need to basically check to see if input dot like is key down, you know, key code dot W, right? Then we can, I don't know, maybe we make some kind of like speed and like some kind of velocity vector or something. And then we'll say that if it's W, then we'll say velocity vector dot, well, velocity dot, I don't know, I guess X, right? Equals 1. Else if S, -1. So I'm gonna write out the code first so we know what to do. And obviously W would have been up, right? So this is Y going up, going down. A is X going that way. And X going that way. So we've got our left and right from our input. Thank you guys for the bless me's. And how do I apply a patch and fork? Repository, apply patch. Little tutorial for Peter there, real quick. Anyway, so let's see. Yeah, so that's basically, so the big thing we need here is key codes, and then what we can do is obviously just do velocity. We can multiply that with our speed. And if that doesn't work, I want to make it work. Yeah, it doesn't look like it works. So, oh, well, because we've just got this here. Let's just do like, what is it? Vector 3, static vector 3, operator, vector 3, vector, float, scalar, return. Yeah, thanks, IntelliSense. That's literally what I'm writing though. Vector.x times scalar, vector y times scalar vector dot z times scalar must be declared static and public. Yeah, I missed the public. Okay, cool. So that should maybe work. Oh, we times equals. How does that work in C#? Like, does that just return? Is that not a static thing? It's just a void thing, is it? Cannot return void, user find promote. That's the wrong one. But that's that, right? How does this work? I need to look it up in my stuff. Ah, I don't even have those. So, how does that work? Or is that just implicitly supposed to work? Because we have that one. Oh, okay. Never mind, it does work. Let's just do vector 3, 0. Here I am adding more work for myself. Okay. Cool. So there we have zeros, we have all of this stuff, everything looks good. So now what we do is basically we want to add in this input API and also key codes for all of this stuff. So luckily key codes are pretty easy because we have them all here. So we could literally copy them as is and set them up, which I guess I will do because that's not that difficult to do. And we're gonna need this stuff. So let's add a new class in C#. We're gonna call this key code. We'll make it public, of course. We'll make it part of the Hazel namespace. And then this will be basically like just like an enum. So how does that work? Can we just do like an enum? I don't know. Don't do this stuff that often in C#. I feel like my C# skills have declined somewhat. Or maybe that's just it. Okay, cool. There you go. We're great. So let's try building that actually. No. Okay, yeah, no, it works. Okay, good. So that's our key code sorted, easy. And now it's just the input API. So if we go back to our main at the moment, which is where we've done everything, then let's add some internal calls. So really there's just one, right? And it's basically static. We'll make it a bool and it's going to be input is key down. Obviously no entity for that. We just take in some kind of key code. Now we can just take in a key code directly, I think, because this is an enum. I don't know what type will be exactly. I'm guessing by this it'll be at least a 16-bit integer, but probably like just an int, I guess, but we'll see how that works out. So that's going to be our input is key down. So if we go into script glue, we'll basically copy that name, put it here, copy this, pop in the name, take in just a Hazel C++ key code, which again should be hopefully the same memory representation, and then we'll just return input is key pressed. Sure, we've got a different name here. What do we call it in is it key? Is key pressed or is key down? What do you guys think? I don't know. Key code, right? Surely that's it. Undeclared identifier. Really? But I just added it. Oh, key codes are undeclared identifier. And where is key code? It's in core. Key codes, and then where's input? Core input. Organize that nicely. Down so it can be up. Yeah, I guess that makes sense. Or whatever, we'll keep the C++ as pressed for now. because otherwise there's no like unpressed or, well, there's released, right? That's the opposite of that. What's your problem? Not returning a value. Oh, what? That returns a bool. Oh, this should be a bool. Okay, great. And then this obviously has a few more errors. So input is key down though, right? Aside from being an internal, like this isn't obviously not this internal thing that we're trying to call here, right? This is an internal call here. So what we actually want to do is we want to make, just like we made with Kiko, we're going to make a class here called input. So we're kind of designing a wrapper over this, right? It's going to be a public class called input, and then it's going to have a public static bool is key down. It's going to take in a key code, and it's going to call internal calls input is key down and return that. So this is kind of how we dress up the API. And then this, meanwhile, is all internal to this Hazel script called binary, even though, yes, at the moment, not everything's there. Yeah, there you go. No, press and down is synonymous. You know, if you want, like, there's typed, which some people, you know, semantically use to mean like just pressed once. But usually if you want it to be pressed once, it's like just checking like the repeat count or something. Okay, cool. Yeah, that's it, isn't it? So then now obviously we can just set translation X to be plus equals velocity, or rather translation should be plus equals velocity times time step. So we're adding that in here. And then we're setting it back. So that obviously doesn't exist because we have to give it that. So let's go ahead and give it that operator. So we'll do public static vector 3 operator plus, and this is going to be a vector, you know, vector A and vector B. So we'll do A, and then B.X, B.Y, and B.Z. Okay, beautiful. So that now should be our completed script. Let's build the script. Let's hit F5 to run Hazel. And we should be Gucci. So, pink cube. We didn't save it, so let's add it again. What is it? Sandbox.player. Hit play. Okay, we're at 0 apparently, which I didn't really want to make that happen. And then also WASD doesn't work. So that's a great start. Why do we reset back to 0? Oh, look, it's trying to move, I think. See? But it's just not really quite working. Why? That should be fine. C# vector addition is wrong. Oh, pff. Yeah, because I copied the multiplication. Thanks, Aver. That's funny. Doing multiplication. Should just save this, but I don't really want this to have the script. Sandbox.player. Awesome. Okay, so now WASD actually moves this, which is pretty cool, right? And we've obviously written that in our C# code. So there you go. That is how we can use what we've learned already with all the C# stuff in Mono to actually basically make a game. So from this you could obviously do whatever you want. The limitation really is just Hazel's API, which you need to really flesh out. And so next time we might do some more fun stuff with the box 2D, right? And everything, because at the moment with the physics thing, like we can't, even though it's actually using the same script, you can see it here, it's not doing anything because obviously box 2D is controlling the physics. So we have to do this to the rigid body. And we could do that, but that's probably going to take a little bit of time, and I'll just leave it for next time. So that's basically it. Cool. How long have I been programming for? like 11 years, I think. So yeah. Yeah, we did. We got a bunch of stuff done today, which is pretty exciting. So I hope you guys enjoyed this episode of the Game Engine series. If you did, then can't really like a Twitch stream, but if you're watching on YouTube, you can hit the like button. And if you really like it, then you can help support the project on patreon.com/Cherno. And next time, as I mentioned, we will probably just flesh out a little bit more of the C# API and do some more kind of fancy things to make the workflow and user experience a little bit better as well. So thank you guys for watching, and I will see you next time. Goodbye.